Makes sense. And it is, do you see g of x right there, right smack in the middle of the table? And do you see the row that says 1? Yeah? So the number in there right now is -3. It needs to be a 2. Okay? So take that -3 and just scratch it out and put a 2 in there. I will do the same thing, and I think this should work out better. I wrote it so well, you almost can't even tell that I wrote it in there. Just kidding. Okay, so I'm talking about this one right here. This needs to be a 2. So please make yours a 2 right there. I think if we do that, it should work out okay. All right, so just by way of review, like what we've been talking about in here in section 3.3, 2 big topics. We've been talking about how to determine whether some quantity is increasing or decreasing, and then we've been talking about finding what? Like what is the other thing we've been finding the last day at least?
Critical numbers.
Critical numbers would help us find relative mins and maxes. And yeah, or horizontal tangents, I agree. So let's say we find our critical numbers like Drew suggested. How do we decide whether those critical numbers really are relative mins or maxes, or maybe it's neither? What do we? It's the first derivative test. And we say, hey, does the sign of the first derivative go from positive to negative, or negative to positive, and or does it not change at all? Does the sign not change at all? And if so, what do those things mean? So let's review that. If you've got a critical number, and right around that critical number, f prime goes from negative to positive, then f has what? Relative min. That's right. But what if you've got a critical number and f prime doesn't change signs around it? Then f has what?
Inflection.
An inflection pointer, and you could say neither a min nor a max, right? And then if f has a relative max, then f prime around the critical number has what pattern? Positive to negative. That all make sense? You remember this from yesterday in the video and all that stuff? All right, so we're going to try that here with example number 5. It says, given that h of x is equal to f of g of x, and the information down below, determine if h of x has a relative min, relative max, or neither at x equals 2 if h of x has only one horizontal tangent. So these tables, I think you can imagine these tables give a lot of information. Odds are pretty good we're not going to use every single number in there, right? But they're going to give you a lot of information to see if you can pick out the important stuff. So if we're going to try to find, do we have a relative min, max, or neither, we need to make sure that we have a good candidate, right? So what candidates, what do we have for candidates as far as relative extrema? Where do we get those candidates?
When f prime equals 0.
When f prime equals 0, or doesn't exist, what is he talking about?
Critical numbers.
Critical numbers. So if I'm trying to find out where h prime equals 0, or h prime doesn't exist, what should I find first? H prime, yeah. Okay, so let's do that. H prime, we've got h of x. So h prime, what rule do we have to use to find h prime? The boxes, also known as the chain rule. Yeah. Okay, so take a minute here. This is very symbolic. Let's see if we can handle this. Please, no comments. You might be thinking about making a comment about this. Please do not blurt anything. No, yeah. Just trust me. Please trust me. Okay. Okay. So what do you think, Alex? What do you think h prime would be for this one?
F prime of g of x plus g prime of x.
What do you guys think? What do you think, Luke?
Is it times?
Should be times.
Okay.
Yeah, when you chain rule something, each of the pieces of the chain are times or multiplied together, not added. So we're good. So times g prime of x. So let's see if we do have a critical number here. So they're asking us to evaluate what's going on at x equals 2. So let's find h prime of 2 before we go too much further here. So this would equal f prime of g of 2 times g prime of 2. So what is g of 2? 3. So I could say this equals f prime of 3 times g prime of 2. What's g prime of 2? Negative 2. And then how about f prime of 3? And that's the key, right? So h prime of 2 equals 0 times negative 2, which is equal to 0. So what does that mean? I think it's always important to ask ourselves, who cares? What does it all mean? Sorry, I interrupted you. What does it all mean?
That's the.
That just means that the slope 0. The slope of h.
Slope of h is 0 at 2, making 2 a critical number, right? So we've confirmed that 2, yes, 2 is a viable candidate. It is actually a place where you could have a relative min or max, or it could be neither. It could be an inflection point. So we've established that as our candidate. We've got to now decide, okay, what is it? Which is it? So how could I decide whether x equals 2 is a relative min or max or neither of h of x? What do you think, Blake?
Plug in numbers below 2 and above 2.
And we would take those numbers, we plug them into what?
H prime.
Into h prime, because it's called the first derivative test, right? It's not called the original function test or something like that. So you can be plugging numbers into h prime to establish these intervals. That's exactly right. Okay, so what numbers would you all suggest or think of that we could plug in? 1 and 3, right? The table gives us some nice convenient values around 2, one below 2 and one above 2. So let's try that out. Let's start off with the 1. So I'm going to say h prime of 1 equals, so it would be f prime of g of 1 times g prime of 1. So you got to use the table, of course, to figure this stuff out. So I will come up here and do so. Got to figure out g of 1 first, I guess. What's g of 1? 2. Okay, so it gives us, bless you, h prime of 1 equals f prime of 2 times, what is g prime of 1? 2, okay. Okay, so finally to figure this part out, what is f prime of 2?
4.
So 4 times 2 is 8. That's a good number and everything, but what's the most important feature about that number? It's positive. Okay, so we've established that h prime to the left of our critical number is positive. So what have we eliminated from the possibilities right now? It's definitely not a relative min. It could be a relative max, or it could be neither if we don't see a sign change. Okay, so if we want to establish this pattern or continue to work on this pattern, let's use, like you guys suggested earlier, let's use 3. So I'd say h prime of 3 equals f prime of g of 3 times g of 3. So how'd this work out? Ben, what's g of 3?
G of 3 is. Isn't it G prime of 3? No.
Well, the second factor is, did I not say that?
Okay, yeah.
I wrote it but didn't say it, sorry. Sorry, g of 3 is 1. Okay, so h prime of 3 equals f prime of 1 times, what was g prime of 3?
G prime of 3 is
What?
8.
2? Yeah, 2, okay. Okay, so then the final step here is figuring out f prime of 1.
So that's negative 1. Negative 2.
Negative 2, okay, so negative 2 times 2, of course, is negative 4. So what's the sign change pattern? H prime went from positive to negative, so we got a relative max at x equals 2. So,
Would we be able to assume if we get a 0 and a positive that the other one's going to be negative?
no, because it could be a positive, then a 0, then a positive, which would give you an inflection point. I'll show you an example of that in a second. So we close this up. It didn't say to do this. Let's just practice this to say h of x has a relative max at x equals 2 because h prime of 2 equals 0 and h prime changes from positive to negative at x equals 2. So just a way to kind of summarize it and conclude. It's always a good idea to do that. All right, so what do you think? Questions, comments, thoughts? I'll try to help you with your thought there real quick, Spencer, but are we good? Are we okay? Okay, awesome. So no big deal. Okay, so if you've had physics, some of this might seem pretty familiar to you. If you haven't had physics, I think I have a good way for you to remember this. but we want to compare velocity and speed. These are often used interchangeably, and they are definitely related, but they are not always the same thing. So velocity, let's talk about what that is. We've talked about this before. Velocity would be something over something. Close. Not change in distance. You're getting close. Displacement over time. Yeah, I'll go with that. So yeah, you could say displacement over time. And displacement is just change in position, right? So you could say change in position over time. So I'll put something like this, like delta P over delta T, change in position over time, something like that. But let's get a little bit deeper here. Velocity is what we call a vector. And speed is scalar. So a vector has magnitude and direction. Okay? So velocity is going to have like an amount, right? It's going to be 20 meters per second or 15 miles per hour or something like that. That's the magnitude. It'll also have a direction. In physics and in other calculus courses, you might have like angles to give you the direction. For us, like all the things that are going to be moving around for us are going to be moving in a straight line. And so our direction is going to involve plus or minus, right? So for us, our vector direction will just be indicated with, is it positive or negative? So typically for us, if the velocity were negative, it means that the particle is moving to the left. That's kind of our standard notation or standard thought process. And if the velocity is positive, it's moving to the right. Okay? That's pretty standard sign convention. So speed is related to velocity. I'm going to put what speed is here. Speed is scalar, as was mentioned earlier. Speed is simply the magnitude of velocity. Magnitude, there we go, of velocity. So in other words, it does not include the directional aspect of velocity. So if you think about this for a second, your car has a bunch of gauges and things in there, right? One of which is speedometer, right? Speedometer, speedometer, it's measuring your speed, right? So if the thing in your car, if the gauge in your car was a velociometer, whatever, if it measured your velocity, think about how that would work. If you're going forward, it would be positive, wouldn't it?
Yeah.
But if you put it in reverse, wouldn't you need like a whole set of numbers for negative velocities? You say, hey, I put it in reverse, so the speedometer goes back the other way to like negative 10. Hopefully not negative 30 or 40. That would be dumb to go backwards that fast. Right? Yeah, it's how fast we go backwards. Negative 50. Well, you know what? I think for most cars, I don't know about newer cars, but I know for sure older cars, they have like the actual, like the needle that moves around on the gauge. If you put it in reverse and you hit the gas, it'll go. It'll tell you you're going like 7 miles an hour backwards. Now, usually if you're smart, you're not like looking at the speedometer as you go backwards. You're like looking at the mirror, so maybe you have not noticed that. Not all cars do that, perhaps, but I know older cars did that. You put it in reverse, and if you happen to notice, the speedometer will actually move up a little bit as you start to go backwards.
No, you think you can hit 71?
I think so.
Oh boy, scary talk right there. So, we'll keep talking about the car example here in a second, but the other thing I want you to think about is as far as a graph goes, guys, this is really important, please don't not hear this. As far as a graph goes or a function goes, the blanks here, speed is the, any ideas?
Magnitude.
Slope, no.
Because the slope of velocity would be acceleration.
Yeah, exactly.
Speed is the,
Position.
Best friend.
Absolute value.
yep,
When you got an 8.
Once
So-
he started
I didn't say that.
speed is the speed function is the absolute value of the velocity function. And hopefully that makes sense to you, because if a velocity function could have positive and negative values, speed, if it is the absolute value, what does absolute value do to all negative values? Reflects them back up to being positive, and so that means that speed could not possibly be negative, right? Meaning that it's scalar. There's no possibility of signage. Okay, so speed is increasing when, speed is decreasing when. I want to give you just a brief demo. Speed is increasing when my velocity and acceleration have the same sign. So when velocity and acceleration have the same sign. And then speed is decreasing when? Velocity and acceleration have opposite signs. Yep. So this will require just essentially a comparison of some values and a conclusion when you're presented with this. And so you can see we've got this example right in front of us. And just a reminder from what I said before, we don't want t equals 5. That's just a bad value for this particular question. So we want to have this t value. I think 2 will work fine. So it says the position of a particle is given by s of t. So I've given you a position function, and then it asks you, is the particle speeding up or slowing down? Or you could another way to say it is the speed increasing or is the speed decreasing? Okay. When t is equal to 2, and you're supposed to justify your answer, so show your work and have one of those concluding statements. Okay? So I think you have enough to try this. I hope that you're successful, but give it a shot, and we will see if you were successful here in just a minute. So did you guys get to a velocity? Did you guys get to a velocity function here? You had to differentiate, right? So I erased my little edit there. So this should be t equals 2 again. Okay, so to get a velocity function, we had to do s prime. So s prime equals v equals, Tiffany, what is the velocity function?
6t squared minus 48t plus 19.
I think that makes sense. Nice work. And then, of course, to get acceleration, Spencer, what do we have to do to that?
Double prime. So
Yep.
you get, let's see, 12t minus 48.
Very good. Okay, so there's your velocity function, there's your acceleration function. Notice that I indicated that I did a derivative, right? Like s prime says I differentiated this thing. And of course the power rule is relatively easy, right? And then I did s double prime to get the next derivative. Again, I'm indicating I did a derivative. So I need to find s prime of 2, right? And s double prime of 2. So I'm going to go ahead and, or you could even say v of 2. So Lauren, what did you get for v of 2?
18.
Do you guys agree with that, 18?
Yeah.
Okay. Annie, what'd you get for a of 2?
Negative 24.
Negative what?
24.
We agree on that too?
Yeah.
Okay, so those are good numbers. What's the most important thing about them? Opposite signs, so speed is decreasing, or you could say it's slowing down, right? So I would say for a justification, because a of 2, well actually I'll do it like this.
Is it slowing down technically a double negative?
Because a of 2 and v of 2 are opposite signs, speed is decreasing.
Could you say s prime of 2 and s prime of 2?
Yep. Yep, s prime, s double prime definitely would be acceptable there. Okay. So guys, that concludes